You are floating 400 kilometers above the surface of the Earth. It is a quiet Tuesday. You are strapped into the cupola module of the International Space Station, holding a foil pouch of coffee. Below you, the world is a breathtaking tapestry of blue oceans and glowing continents. You are watching the sun set over the eastern seaboard of the United States. The cities begin to light up, forming that familiar glowing web of human civilization that astronauts have admired for decades. And then the lights go out. It doesn't happen with a flash. There is no visible explosion. It is just a sudden, absolute wave of darkness. New York disappears, then London, then Tokyo. Within seconds, the entire electrical grid of the planet vanishes into the void. The Earth becomes a black, featureless sphere against the cosmos. Your training kicks in immediately. You reach for the radio, pressing the comms button, expecting mission control in Houston to explain the anomaly. You ask for a telemetry update. You ask for an abort protocol. But there is no voice. There is only the cold, sharp hiss of static. You don't know it yet, but you are now the last isolated human being alive, and the multi-billion-dollar machine keeping you breathing is about to become your tomb. Your first instinct is a localized system failure, a blown fuse, a damaged antenna on the station. But the science of space communication tells a much darker story. The International Space Station does not talk to Earth through a single radio tower. It communicates through the Tracking and Data Relay Satellite Network, known as TDRS. It is a flawless, redundant system of geostationary satellites bouncing signals across the globe to multiple ground stations. For that static to exist in your headset, it means millions of servers, thousands of miles of fiber optic cables, and countless backup generators on Earth had to die simultaneously. The silence on the radio is not a technical glitch. It is an extinction event. Psychologists study a phenomenon called the overview effect. It is a cognitive shift that astronauts experience when seeing Earth from space. Usually, it brings a profound sense of peace and interconnectedness. But right now, your brain is processing a terrifying new reality. You are trapped in a titanium cylinder, traveling at 28,000 kilometers per hour, and there is absolutely no one driving the ship. To understand your impending doom, you must first understand the physics of your orbit. Most people believe that the space station floats in zero gravity because it is far away from Earth. This is a misconception. At an altitude of 400 kilometers, Earth's gravity is still nearly 90% as strong as it is on the surface. You are weightless because you are in a state of continuous freefall, moving sideways so fast that you keep missing the planet.
But space at this altitude is not a perfect vacuum. The ISS exists in low Earth orbit. This means it is constantly swimming through the exosphere, a very thin, invisible soup of atmospheric particles. Every single second, this extremely fragile atmosphere creates friction against the massive solar panels of the station. This is called atmospheric drag. Normally, this is not a problem. Mission Control continuously monitors this orbital decay. Every few weeks, engineers in Russia or the United States send remote telemetry commands to the Zvezda service module, firing its thrusters to boost the station back into a safe, higher altitude. Without those engineers, there are no boosting maneuvers. Physics takes over. Gravity becomes an invisible, relentless anchor. Day by day, kilometer by kilometer, the station is being pulled down into the thicker layers of the atmosphere. Left completely unchecked, the International Space Station will eventually heat up to 3,000 degrees Celsius, disintegrating into a fireball of melting aluminum and steel. But gravity is a slow killer. It might take a year or two for the orbit to decay completely. You will not live that long. Something much faster is already hunting you. Look out the reinforced glass of the cupola. You share this orbital highway with nearly 10,000 active satellites. Weather monitors, military surveillance, global positioning systems, and massive communication constellations. Maintaining this orbital ballet requires constant human intervention. Ground control stations track millions of pieces of space debris, calculating trajectories and sending collision avoidance maneuvers to keep everything safe. Without human engineers adjusting their paths, these satellites become blind, dead metal, moving at 10 times the speed of a bullet.
In 1978, NASA astrophysicist Donald Kessler predicted a nightmare scenario. He warned that if the density of objects in low Earth orbit became too high, a single collision could trigger a catastrophic chain reaction. One dead satellite drifts into another. They impact at 20,000 kilometers per hour, instantly vaporizing and creating a massive cloud of shrapnel. That cloud spreads out, acting like a cosmic shotgun blast, tearing through dozens of other satellites, creating even more debris. This is the Kessler Syndrome. And without ground control, it is no longer a theory. It is a mathematical certainty. You are floating inside a highly pressurized balloon in the middle of a supersonic shooting gallery. You have no radar to warn you. You have no engines to dodge. A fleck of paint moving at orbital velocity has the kinetic energy of a hand grenade. It can easily crack bulletproof glass. A stray bolt or a piece of solar panel will tear through the Kevlar shielding of the hull like wet paper. When the shrapnel storm hits, explosive decompression will violently suck the air from your lungs into the vacuum of space in less than a second. But let us assume you are incredibly lucky. Let us assume the debris storm misses the station entirely. Let us assume the hull remains perfectly intact. Your final enemy is the very system designed to keep you alive, the Environmental Control and Life Support System, or ECLSS. The space station is a closed-loop environment. It is a marvel of human engineering that recycles absolutely everything. The water recovery system collects the moisture from your breath, your sweat, and your urine, filtering it back into pristine drinking water. The oxygen generation system uses electricity from the solar panels to separate water molecules into breathable oxygen and hydrogen gas. But these incredibly complex machines are not magical. They require constant maintenance. They require chemical filters, replacement parts, and software updates sent from Earth. Parts that will never, ever arrive.
As the weeks pass, the machinery begins to fail. The most critical component is not the oxygen generator. It is the carbon dioxide scrubber. Every time you exhale, you are filling the station with a toxic gas. The scrubbers use specialized zeolite materials to trap this carbon dioxide and vent it into space. When the scrubbers finally choke and shut down, the invisible gas begins to build up in the ambient air. You cannot smell it, you cannot see it, but your body will feel it. hypercapnia sets in. First comes the dull, throbbing headache, then the intense fatigue and confusion. Your breathing becomes rapid and shallow as your brain begs for oxygen that your lungs cannot process. Your heart races, pounding violently in your chest in the absolute silence of the microgravity environment. Panic is a chemical reaction you can no longer control. As the carbon dioxide levels reach critical toxicity, your vision begins to narrow. The edges of the world fade to black. You float over to the copula one last time, your muscles heavy, your mind slipping away. You look down at the dark, silent earth slowly spinning in the void. No city lights, no radio chatter, just a graveyard of a civilization that once reached for the stars. You are the highest human being in the universe, the absolute pinnacle of our technological evolution. You are surrounded by the most advanced machinery ever conceived by mankind, and yet you have never been more utterly powerless. Technology gave us the stars, but it also tethered us to the ground. Without the collective effort of billions of minds working below, the greatest machine ever built is nothing more than a metallic coffin falling slowly from the sky. When you look up at the night sky and you see a satellite drifting silently across the stars, remember the fragile, invisible threads that keep us alive. Remember the thin line between a triumph of engineering and a technological trap. This is the silent observer. Gravity is patient, and the void is always waiting.